Hi, this is Eli Atelovich of the Delta Modeling section of the California Department of Water Resources, and the topic for this session is subsetting bathymetry for use in Aquavio SMS using the clip DEMs utility that we distribute in the Schimpy Python package in our GitHub repository. We'll be assuming both a working Schimpy installation and some familiarity with SMS in this tutorial. One of the first questions that comes up is why subset at all? Doesn't SMS handle multiple DEMs or large DEMs? And the answer is yes, if they're reasonably small. A lot of the functions, such as aligning meshes with a contour, can bog down if the meshes that you input in the interface are too large. And our DEMs are not small either individually or as a collection. Also, historically, SMS didn't handle prioritization well, or perhaps I should say didn't handle it exactly the same that we did. It's important for the elevations that you see in SMS when you're working on a mesh to match up with the methods that will ultimately be used to populate the grid. Typical workflow with clip DEMs is to zoom to the work area of interest inside of SMS, save as JPEG to create an image that defines your area of interest, run clip DEMs using that image as input, and then when the clipped DEMs are produced, you re-import them back into the SMS session. Okay, let's look at a clip DEMs example using an SMS session for the Bay Delta mesh. First step, I've zoomed in on an area of interest near the Delta Cross Channel in the northern Sacramento River area. I'm going to save as a JPEG. I'm fine accepting the default name, baydeltasample.jpg. In this case, I've used it before, so it's going to be an overwrite. And now we go to a command prompt with Schimpy environment enabled, and we execute the command clip DEMs. Image is going to be baydeltasample.jpg, the file that we just created. Prefix is DCC for Delta Cross Channel. That's going to be used in naming the output, something we'll get to later. And I've also added the name of a file, DEM 4.1 base.yaml, that's in this directory that has a DEM list. I'm going to press execute. It's going to rifle through the DEMs. Every time it gets a hit, you get output that names the data set that was overlapping and the output file of the clip DEM associated with that file. So you can see there were actually quite a number, 0 through 4, so 5 total hits on DEMs within our elevation model package. I'm going to just kind of hope that we got lucky and that the DCC 0, which is the highest priority of the outputs, is relevant and covers at least most of the area that I'd like to look at. And you can see that indeed that's the case. When you import an ASCII DEM, it becomes GIS data. Normally you have to convert to a 2D scatter in order to get data that you can work with for things like contour alignment. If this had been incomplete, as it was in some of the fringes, you could also import dcc_1.ascii and see if that takes up the slack. Here is the help for the clip DEMs utility. Notice that clip DEMs is called without a .py extension. It's an executable script that's part of the Schimpy package. The arguments are straightforward. You have the option to import either bounding coordinates or an image whose extent represents those coordinates. We almost always use a JPEG image. This leads to a faster workflow. The prefix argument is used as a stub for output file names. I'll get to that in a moment. Out format allows you to output DEMs in formats other than the default ASCII. The codes for that come from the GDAL package. H-shift is a deprecated argument that makes up for an old bug in SMS centering the DEMs. We won't be using that. DEM list, the positional argument, is a file that contains a prioritized list of DEMs. This is an example. This particular example file is in YAML format, but you can also use a straight text list. Pound signs are comments. The priority within this file goes from top to bottom. So the preferred DEM is the one that's towards the top. How the script works. Clip DEMs will search every DEM on your DEM list. For every DEM that is a hit, in other words, that overlaps with your extent of interest, it will create a clipped version that is limited to those bounds. Then it uses prefix plus a number to form the output file names. So northsac_0.asc is the output that comes from clipping the highest priority on your list that was a hit. When it comes time to re-import the DEMs in SMS, it's a simple file open or drag and drop. Typically, you will be using the _0 output from clip DEMs, but sometimes that's a small file or doesn't completely cover the area, so you use a combination. Please check that the file output size is not unreasonably large before you import it into SMS, because really big DEMs can kind of hang SMS. 80 megabytes is efficient for 12 gigabytes of RAM. You could probably get away with double that size. Okay, in summary, clip DEMs is essential for using SMS efficiently on some operations, so it tends to be an ingredient in a lot of other tasks. It preserves the priority, alignment, and resolution of your inputs, and it's consistent with the way we populate the grid later. If you've got any questions, please direct them to me or another member of the section. Thanks for listening.